Hi everyone, I'm Heng from CMU. I will present our paper, CoNFies Controllable Neural Phase Avatars. This project is supported by FUJITSU Research of America. We know that neural radiance feeds, or NERF, are compelling techniques for modeling dynamic 3D scenes from 2D image collections nowadays. NERF can also be well suited for synthesizing novel facial expressions. We are interested in fine-grained control of complex avatar expressions. One related work is CoNFies, which is proposed as a controllable neural representation to achieve simple manipulation using a learned mapping between a segmentation mask and a control signal. We can see from the videos that CoNFies fails to achieve fine-grained control in the complex expression scenario. To achieve fully automatic fine-grained control over face avatars, we propose CoNFies, and we show that our method can successfully control the complex expressions. CoNFies also cannot achieve good localized control, which means that control of one part can affect other parts. In the left result, we can see that when we control the eye opening, the mouse in the CoNFies result also moves. In the right result, we also can see that when we control the mouse opening, the eyes in the CoNFies result moves. From the videos, we can see that our method achieves better localized control. Next, I will introduce the pipeline of our method. The first step is video recording. Users record themselves using a circular motion. The circular motion captures the face with different expressions from different angles and enables 3D reconstruction using photometric consistency. We also use slow-mo recording to capture subtle expressions and to shorten the recording time. The second step is face tracking and AU coding. The recorded video is tracked and processed for action units. The tracker provides 2D facial landmarks and facial action units intensities. Here the video is speeded up for demonstration purpose. The third step is dynamic masks and control. The 2D landmarks are used to calculate different semantic masks on the face. Each of these corresponds to a group of action units that affect the same face region. These AO intensities are used as control labels during training. The fourth step is building phased hyperspace. We built a phased hyperspace using the original 2D frames, calculated dynamic masks, AO intensity labels, and camera parameters. These space models time varying shapes with topological changes. After training the whole system, novel views and expressions can be generated using different AU intensities and viewing angles. Here we show our network architecture. We learn K attributes noted as alpha from latent deformation code using attribute network A. Different from CoNFies, we use change as activation function in the last layer of A to learn attributes in the range of -1 to 1. K original hyperspace components are generated using sampling 3D points X and corresponding attribute alpha, and we also generate one hyperspace omega 0 for the remaining avatar part. After obtaining the original hyperspace, we then learn N masks according to a predefined correspondence between attributes and masks. Final hyperspaces are obtained by masking the original hyperspace using corresponding masks. The whole hyperspace is obtained by concatenating all the final hyperspaces, and the final density and color are obtained using the same way as template NERF. The losses of our method consist of reconstruction loss, a regularization term on the latent codes, attribute mask loss, and attribute value loss. For more details, please refer to our paper. Here we show the results of our method. We fix the viewpoint and control the AU intensity from -1 to 1. We can see our method achieves good control using different AUs. Here are the results of another sequence. We can also fix the expression using different AU combinations and changing viewpoints. We show the RGB maps, depth maps, and masks generated by our method. Here we show the results when changing expression and viewpoint simultaneously. In addition to adjusting AU values manually to control the avatar's expression, it is possible to copy them from another person's face. In this case, first we detect the AU intensities from the source person's face, and then use them to resynthesize the same expression on the avatar. Here we show the rendering results using another phase sequence to control the trained sequence. Thank you so much for listening. Please visit our project page if you are interested in our work.